we look at the problems with our normal distribution, there's one thing that would be really helpful for you to do, kind of on the side of the page or at the top of the page or something like that, that'll help make all the rest of these problems super easy. Okay? And that is figure out your percentages ahead of time within each region. Okay? Hello.
Is Shelley in school?
Oh. Hi. What's your name?
Miha.
Miha.
He's 37 level.
Nice to have you. Alright. Alright, so as we look at this is what I would sketch, okay? We've got our mean in the middle, we've got 1, 2, 3 standard deviations to the right, 1, 2, 3 standard deviations to the left, and let's figure out the percentages. Okay, so a little review of yesterday as well. Within 1 standard deviation is how much?
68.
68. So each of these is how much? 34. So write it in there. Okay, 34 and 34%. Okay, within 2 standard deviations is how much? 95. So that's an extra 27%, right? So if I split that up evenly, how much is in each of these ranges? There you go, 13.5. Okay. Now, from 95 out to a third standard deviation, that's how, what percent? 99.5. So, another 4.5% split up. 2.25. Okay. 2.25. Okay. This is 2.25. And then that leaves, since that's 99.5%, that leaves another 0.5% outside of that, beyond 3 standard deviations. So on either end, there's how much? Yeah, there you go, 0.25. Okay? So right there is 0.25. So now, when we approach a problem like number 4, first of all, make a real quick sketch of your situation. Our mean is 184. And the standard deviation is 5. So here's 1, 2, 3 standard deviations. And you just count up by 5. 189, 194, 199. Okay? And then you go 1, 2, 3 standard deviations to the left. 179, 174, 169. Okay? And there's your bell curve on the left, bell curve on the right. Okay? So now when you're asked to figure out what percentage of the players are taller than 189 centimeters, you come over here and you look, oh, that's 1 standard deviation above the mean. So what is all of that? Well, according to this, it's 13.5 plus 2 1/4 plus 1/4. So what percent is that?
16.
That's 16%. So 16% approximately of the ball players are going to be over 189 centimeters. Okay? And then for each one, you can just figure out what regions do I need. Okay? What region is it looking for? Okay? So taller than 179. Okay? That's 1 standard deviation below. So we want this way, right? So 34, 34, 13.5, 2 1/4, and 1/4. So 84%. Okay? You can also do between. So between 174 and 199. Okay? So that's between here, and that went down 2 standard deviations, so here. So you add all those up. Okay? One thing with this one, though, I'll point out. Don't forget your complement principle. all the percentages add up to 100, right? So if I want all of these, I could just say, well, that's 2.5 plus this is a 2 3/4. So 100 minus 2 3/4 is 97 1/4. Okay? That's another way of doing the same problem. Don't forget that complement principle. Okay. Our last one, how many are over 199 centimeters? 0.25%. Okay. So 1 out of every 400. Number 5 is the same problem. We're just talking about rainfall in Claudona instead of heights of basketball players. But the concept mathematically is the same. Okay? Numbers 6 and 7 are almost identical. Okay? So look real quickly at 6. And then 6 and 7, like I said, are almost identical. It's just in 6 we're talking about lifeguards, you might hear them. These aren't candy. Okay? Okay, 200 lifesavers or lifeguards in a swimming race. And down here we're talking about the weights of newborn babies. Alright? But they're the same problem. Okay? Because here we look at our mean is at 10 minutes. Okay? Well, let me just use the diagram we have here. This is 10 minutes, 30 seconds. Okay? Standard deviation is 15 seconds. So if I go up, I have 10 minutes, 45 seconds. And then I have 11 minutes. And then I have 11 minutes, 15 seconds. Okay? If I go down, it's 10 minutes, 15 seconds, 10 minutes, and 9 minutes, 45 seconds. Okay? So, the difference in this problem is the fact that they aren't asking for the percent. Okay? We're looking for a number of competitors. So after we figure out the fact that, 2.5% took longer than 11 minutes, then what do we do with that? Multiply it by 200 lifesavers, because it's 2.5% of those racers. So that would be 5 people. Okay? So those are the 5 you don't want coming to save you. Alright? Because you'll probably drown by the time they get there. Just kidding. These are the guys you want coming after you down here. Okay, the fast swimmers. Alright, does that make sense? Pretty much? Okay, alright. There is one that's kind of different. Number 9. Okay? Number 9, we're not told what the mean or standard deviation is. Okay? So we have to think in terms of our diagram and what we're given. Okay? So here we have Jason. He's growing oranges. Alright, you like oranges?
Yeah.
Okay? Alright, so Jason is growing oranges, but we don't know what the mean weight of each orange is. However, we have somehow figured out that 84% of the crop weighs more than 152 grams. So 152 is somewhere down here. Okay, since that's more than 50%, I know it's to the left of my mean. Alright, so from here over is 84%. Okay? Now, looking at this diagram down here, where is 84%
And then to the right of that.
To the right of -2 standard deviations?
Oh wait, no,
Right.
the other, next.
Yeah.
Right, -1.
-1 standard deviation, okay? So here, that's 84%. So we know that whatever the mean is, this is the mean minus 1 standard deviation. Okay? Now, we are also told that 16% weigh more than 200 grams. Well, 16 is less than 50%, so since I'm going more, I know that less than half of it's going to be above here, so I'll put this 200 about right here, and I know that this is 16%. Alright, so where on our diagram marks 16% above it? Yeah, it's 1 standard deviation above. Okay? So that's 16%. Now, we could have solved this even if it was -1 and then a +3 or something like that, because if you notice what we have, mean minus the standard deviation is 152, the mean plus a standard deviation is 200, we have a system of equations.
Yes.
And if we solve that system, we can figure out what the mean and the standard deviation is. Okay? Now, if you think about it logically, since it is 1 below and 1 above, we can figure it out logically too. How are we going to get our mean?
Well, you can add the two
Add them
numbers.
and
And
divide by
then-
2.
Yeah,
You could
if this
divide
is
by 2.
1 below and this is 1 above, then if I average the two, I'll get right in the middle, I'll get the mean. Okay, so what does that end up equaling?
176.
176, okay? So 176 grams is the mean, and
You can
that means the standard deviation has to be 24, okay? So mean is 176 grams, standard deviation is 24 grams, okay? So now, what's the percentage that go between 152 and 224? Well, I've got to go another standard deviation to the right here to get to 224. So now I've got this 34, and the 13 and a half.
81.5.
81 and a half, yeah. 81.5%. Okay?
Yay.
So there's some good logic with these, but there's also, you gotta remember things. You've gotta remember your 68, 95, and 99 and a half. Okay? If you don't remember those, you're not gonna be able to do any of these. Okay? If you want, you could just memorize the 34, 13 and a half, 2 1/4, and 1/4, and you know that's half, and it's just mirrored on the other side. What?
That part is 34 and this part is 13.5. Is decided or should be changed?
No, it's not gonna change. Every normal distribution has those percentages, yes, okay? Alright. Now, where it's challenging, okay, is what if we don't want just these nice ones that end up right on the standard deviation, okay? For example, and this is where we're getting into new stuff, guys, okay? For example, what if I wanted the percentage or the probability, it's going to be the same thing. What if I wanted the percentage of these oranges that were between 160 grams and, let's say, 190 grams? Okay? So what percent of the crop lies in that region? Alright, that's what we want to look at today. We're just going to look at this one thing, and then I'm going to give you guys some stuff to practice with it, okay? We are going to use your calculator, so go ahead and get those out so you're ready when we get to that part, okay? So, how do we find probabilities with our calculators, okay? First of all, do not write down what I'm about to show you, okay? You're not going to need to do this, but I want you to understand where this comes from. Otherwise, you know, you're just punching numbers on the machine and not really knowing what you're doing, okay? We've learned about the probability density function. We saw this kind of nasty looking function here. Okay, that's our probability density function for the normal distribution. Okay? And we saw that that's a Gaussian function. It gives us a bell curve. Okay? The probabilities, though, that we've been finding, that 68% and the 95%, those actually are areas. Okay? For example, here we have a normal distribution where our mean is 0, and then we go down 3 standard deviations and up 3 standard deviations. If I found the area from -1 standard deviation to +1 standard deviation, okay, if I found this area right here, that area would equal 0.68. Approximately. Okay? So we're really finding areas. And that brings us to what we're really going to be doing here. And when we're finding the probability that a certain value is between two numbers, we're really finding the area under the curve between those two numbers. And as you guys will learn next year, whether you're taking SL2 or SL1 or AP Calc, the area under a curve is the integral. Okay? It's the integral of the function, okay, from one side of the interval to the other. So it's the integral from a to b of f of x dx. Okay? Now, I know you guys don't know how to do integrals yet. That's okay. You're not going to have to. Alright? But when we use our function on our calculator that we're about to look at, this is what it's doing mathematically. You're going to provide it with the boundaries, a and b, and you're going to provide it with the mean and standard deviation. It's going to use this function and integrate it over the interval. Okay? So, it's kind of cool what your calculator can do. But what's nice is that we don't have to just go on these nice even standard deviations. We can find it for any value. Okay? So let's look at this function on your calculator. The name of the function is called normal CDF, or if you have the N-spire, they drop the AL. It's just norm CDF. Okay? But if you have the 83 or 84, it's called normal CDF. And the way you can find that, without scrolling through your whole catalog, is right here. If you hit second variable, so you have distribution, DISTR. Okay? If you do that, you'll find normal PDF and normal CDF. Okay? Let's reopen that. So, I hit second distribution. Do not use normal PDF. Okay? That's used for graphing. If you wanted to actually graph the density function, you could. Okay? And you could use that. Normal CDF is the cumulative distribution function. Okay? So we're going to choose number 2 here. And then, some of your calculators will then ask you for a lower bound, upper bound, mean, and standard deviation. If they do that, great. If not, you're gonna have to just remember what order to put things in. Okay, you'll see mine here just gives me normal CDF, and then I have to type in a lower bound, upper bound, then a mean, and then a standard deviation. Okay, so let's go back to our problem with the oranges for a moment. Now we said we wanted the probability that a randomly picked orange would be between 160 grams and 190 grams. So I'll punch in 160 as my lower bound, 190 as my upper bound, and then my mean, which we found was 176, and then my standard deviation, which we found was 24. Okay, close your parentheses and hit enter, and 46.8, if you round it to one decimal, 46.8% of those oranges are going to be in this weight range. Okay? Or to think of it in other terms, if you picked a random orange out of a crate, you'd have a 46.8% chance that it will weigh between 160 and 190 grams. Okay? So, anyone have any questions or anyone not get that on theirs? Okay. If you use the Nspire, you actually have it easy if you remember what it's called. Because you can just type in norm CDF.
No, it doesn't work.
Don't type in normal, just type in norm. It's different on the Nspire. Okay? Normal, just norm CDF, hit parentheses, and then you can type them in the same order here. Okay? Yes?
Excuse, can you teach me how to use it?
Now put parentheses. Oh, put the F back. Alright. And now you type in the lower bound, so 160, and then the comma, 190, comma, then the mean, 176, comma, and then standard deviation, 24. And then hit enter.
That's the answer.
That's your answer. Yeah. That's all there is to it. Did you get it? Okay. Did everyone? Okay. Hey, while we're looking at it, okay, try one of these on your own. Okay. Here's a different one. Try that one.
Writing a message and your will prevent you from getting it.
Yes. So.
Do I need to make graphs?
No, you don't need to grab it. You just go to your calculate. And it's called norm CDF. NORM.
Oh, what'd you get?
CDF.
Yes.
Okay, and then put parentheses. Okay. And then in your parentheses, you have to put your lower bound. 160 is the lower bound.
是怎么看到后面变成时间的
190 is the upper bound.
他自己给我们显示
And then your mean is
有设置。
In this case, it's on your bound.
our lower bound, we decided to make it precise. It doesn't have to be right on it. It's okay? So we're going from 160 to 190. We use the mean 176. And then comma. The standard deviation. So the government cap 46 point content.
这哪里是这样？我发的是什么呢？
这个地方有这个说，这个好方便。
这个好很方便啊！你们还要看病，我们直接叫了以后，然后也不好。
我们也是，
一样。
我是跟他不一样。
So now, how would you do this one?
主要帮我把命和什么命说出来。
看这件事，这个更高科技。
因为我觉得那个很好看，这个好看很多次，看到
然后领略我们这个在讲什么？
怎么看到这个好看很多？
啥？
因为太好了嘛。
明显这个比这个好。
难看我才没买。
现代化，有点像。
这个怎么看就是该有的计算器样子，你看就是一个像白板的，好丑啊！我写的是这种，不想骂谁。
哎，你先等一下，我再测试一下，之后费电。你多少钱推荐？
不用充电。
All right, guys. What'd you get for your answer here?
77.5%.
All right, 77.5%. Okay. Look up here. 77.5%. That means whatever this data is, if we picked a random number in that data, we have a 77.5% chance that it's going to fall between 3.5 and 6. Now think, does this actually make sense? Well, if our mean is 5 and our standard deviation is 6, okay, or is 1, then up to 6 is 34%, right? And down to 4 is another 34%. If we went all the way down to 3, that would be another 13.5%, taking us to like 81.5%, right? So we know our answer. This is where it's real easy to type in something wrong on your calculator. So think. This is 81.5% of the thing. 3.5 would take us to right here. So I know it's bigger than 68 and less than 81, right? So if I got like, 60%, or if I got 95%, I know I hit a wrong button somewhere. Okay? Yes?
Can we do it like by ourselves? Like not using the calculator? Because since you know it's the half of 3 and 4, you can split 13.5 in half.
It's not proportional that way.
No.
It's not an exact half. Because if you look at the area here, this area is greater than this little area. The reason why we could split the 68.5 is because we had symmetry.
Okay.
Okay? That's a good question though. Now, one other thing that we have to deal with is, what if we're only given one boundary? Okay? What if we're only given one side? Okay? And there's two ways you could handle this. Alright? How could we find what percent of the data lies above 3.8?
You can go up to the third standard deviation, and that'd be your second one, your upper bound.
Well, but I don't want just the stuff from 3.8 up to the third standard deviation. I want the 3.8 up to infinity. It's not a bad thought, but what do you think?
Like, your upper bound be like 99999999999.
Yes. Basically, yes. Okay? Pick a huge number, or in this case, huge meaning for the situation. Think about this. If I pick 10, that's 5 standard deviations above the mean, right? What are my probabilities changing by at that point? Like millionths of a percent, right? So you could pick 10, or you could pick 100 or 1,000 or some big number, okay? So I could do normal CDF. And I could put in 3.8 as my lower bound, and then I could just put in some really big number.
11.
999. Okay?
Everything else is the same, right?
Everything else will be the same. The mean is still 5, the standard deviation is still 1. Okay? If I wanted it to be less than 3.8, then 3.8 would be my top bound, and I'd put a really small number, negative 30. Okay, as my lower bound. Alright? That'll give us the answer. Another way of doing it that actually is a little more exact would be, you notice this is below the mean, right? Okay? What is the percent of everything above the mean? 50. So what you could do, and I'm not saying you have to, you could say, okay, this is everything to the right of the mean,
And then you find it's the left.
and then I just need to add what is to the left. So that would be between 3.8 and in this case, 5. Okay?
Wait, what did you just say?
What I just did,
Like, how did you
Was-
get 50%?
what I did was this. I recognized that here's 5, here's 3.8, okay? I know from the fact that this is symmetrical, and this is the mean, that all of this is 50%.
Yes.
That's that. So, if I do this, that'll give me
Oh.
just that area to add to the 50%. Okay? Either way, with our rounding, it's not going to make a difference. Okay? We're talking about differences in the millionths of a percent or something like that, or even smaller. So it's not going to make a difference. Either way you like it, though, you can do that. All right? Questions? Comments? Anything? Okay. All right, we're going to stop the video there, and then I have a couple of things to give you.